All right, ladies and gentlemen, welcome to lesson 1.3. We are going to use midpoint and distance formulas. Ironically, someone just mentioned about formulas, and here it is. It's coming to a head. Now we're going to have to deal with some formulas. All right, so make sure we first write down the definitions of a midpoint. It is a point that divides or bisects a segment into two congruent parts. Remember congruent? We just talked about that yesterday. AKA equal, right? By midpoint divides or bisects, right? Splits in half, equal. All right. Segment bisector is a segment, ray, or line that intersects a segment at its midpoint. So in the middle, right? Directly in the center. So a segment bisector might look something like this. If I had a point here, Q, and a point down here. Oh my, I'm sorry. Here's Q, here's T, they're connected. Oh, well, yeah, it's connected. Don't worry. And then we have another point here, connected to another point here. Let's say this is P. This segment bisector, let's say this is point R. That QT is a bisector of MP, meaning each segment on either side are congruent. All right, we can measure the segment with a ruler in centimeters on the bottom here, but I'm gonna go ahead and just say, right, because obviously my screen is ginormous, and if I don't know if I gave you all a ruler, but I'm telling you that these are congruent, right? The notation would be little hash mark here. I can also say that the segment VM is congruent to the segment WM. I could have said MW too, it doesn't matter, okay? Just remember that this means congruent. All right, so now we know that M is the midpoint, meaning M is directly in the middle, so that these two sections are congruent. So we're going to use algebra, meaning solve an equation, solve for the variable, to find the length of the segment. So remember, finding the length, that means we have to plug stuff in, okay? So if I know that these two segments are congruent, my equation is going to look like this. 4x minus 1 is equal to 3x plus 3. Subtract 3x. And get x minus 1 is equal to 3. Add 1, and we get x is equal to 4. Okay? That's half the answer. I need to know what the whole length is, right? So we're going to plug it in. So I'm going to say 4 times 4 minus 1. Well, 4 times 4 is 16, minus 1 is 15. Then I plug it in over here 3 times. Oh my goodness gracious, my pen's doing it again. It's crazy. 3 times 4 plus 3. Well, 3 times 4 is 12, plus 3 is 15. They are both equal to 15. The length of the entire segment would be 30, right? Because 15 plus 15 is 30. All right. All right, let's take a look at the other side of what we got going on here, all right? All right, first we are going to graph these coordinates on the coordinate plane. I think yours might be a little different than mine, but it'll be okay. We got the same stuff going on here. And I'm so sorry that the writing is really small here. Hopefully you guys can see it, but you should all have this paper in front of you, okay? So first, the midpoint formula that we need to all know is like the average of my x's and over the average of my, not over. It's an ordered pair, I'm sorry. I'm trying to write this and type and talk at the same time. It's not working out, okay? So it's like finding your averages, right? You find your average of your x's and your average of your y coordinates, and that is an ordered pair. That's the formula, okay? So when you plug it in, it's going to give you an ordered pair, a coordinate. So now let us use these points, right? Here's my x1, my y1, here's my x2, my y2. Okay, so if I plug it into this formula here, I have 5 plus negative 3, or 5 minus 3, all over 2, comma, 5 plus negative 4, which is 5 minus 4, all over 2. Now I need to simplify this. 5 minus 3 is 2. 2 divided by 2 is 1. 5 minus 4 is 1. 1 over 2 is still 1 over 2. You could write 1 comma 0.5. That would not be wrong. But that is the midpoint with those endpoints. All right, next in number 2, I have the coordinates of find the coordinates of the midpoint with these endpoints. And I'm really not sure why I have this coordinate plane up here now that I look at it, but let's just keep going. Okay, so negative 2 will be my x1, 7 will be my y1, 6 will be my x2, negative 1 will be my y2. We're going to add our x's together. 6 plus negative 2 is really 6 minus 2. All of that divided by 2. And then I add my y's together. Negative 1 plus 7, all of that divided by 2. Now I simplify. 6 minus 2 is 4. 4 divided by 2 is 2. Negative 1 plus 7 is 6. 6 divided by 2 is 3. Now my midpoint is 2, 3. All right, here's where things get a little bizarre, but don't freak out, okay? Because now we know that the midpoint is this, right? The midpoint of JK with endpoints M and J. Did I mess this up? Am I misreading this? Find the other endpoint K. Okay, we are looking for an endpoint K. So K is some X comma Y that we are going to put together with J and set equal to this midpoint. Okay, so I know that you're like, what the heck is she talking about? But look, well, here's what I'm going to do. I'm going to take the points from J and the point from K, and I'm going to set up my equation like I was doing. I know it's an ordered pair, so I know that negative 3 plus some x divided by 2 is equal to the midpoint. The midpoint here is 1, right? Because I'm simply talking about my x coordinates. When I do my y coordinates, I start with my y in J, which is 2. I add some random y here in K. All of that divided by 2 is equal to this y value, 4. All right, so now we just have to do a little bit of algebra to solve these. So I'm going to do them one at a time. So first thing I'm going to do is get rid of this fraction, multiply both sides by 2. Negative 3 plus x is equal to 2. Add 3, x is equal to 5. Same thing, I'm going to do the same steps here. I'm going to get rid of this 2 in the denominator, so I multiply both sides by 2, and I get 2 plus y is equal to 8. Subtract 2, y is equal to 6. So that meant that random point for k, so k is now equal to 5, 6. Okay, we got that from down here. Okay, this is definitely something that people do struggle with, so make sure you are copying this down. I might have gone a little fast with that one, but for this next example, it is going to be the same, okay? It's like the same process. We're looking for an endpoint. I'm looking for an endpoint Q, some x comma y. So it says the midpoint of segment PQ with endpoints, the midpoint of PQ with endpoints M5, 3. That's the midpoint, 5, 3. One of your endpoints is negative 5, 12. So I'm looking for Q from the segment PQ. I know that P is equal to negative 5, 12, and I know that Q is some random x, y. We know the midpoint is 5, 3. So if I strictly start with my x coordinates, I know that negative 5 plus some x, all divided by 2, is equal to 5. Okay, multiply both sides by, oh my goodness. Multiply both sides by 2. Negative 5 plus x is equal to 10. I add 5 and x is equal to 15. Okay, so I have a 15 here for my x coordinate for my random point Q, okay? Now I need to find my y coordinate. So we use our one endpoint 12 plus our other endpoint y, all of that divided by 2 is equal to my y coordinate of my midpoint, 3. Multiply both sides by 2. 12 plus y is equal to 6. Subtract 12, and y is equal to negative 6. Negative 6, right? So my Q, my point for Q is 15 comma negative 6. I probably should have wrote that all in orange. So this is Q. We found Q. We found it. There it is. 15 comma negative 6. All right, so it's just the averages. The tough ones are when you're looking for the end point. I'm pretty sure finding the midpoint will be very simple. You're just plugging it in and chugging along. Now, take a breath because the distance formula is a bear. Okay, please make note, the distance formula is a formula for computing the difference between 2 points in a coordinate plane, proven by the Pythagorean theorem. All right, so we're going to plot these points on the coordinate plane. I think I might have this on the next slide. Oh, nope, I don't. But here's what I'm going to do. I'm going to plot these points on my coordinate plane here. 1 comma 1 is right here, so this is A. 7 comma 9, so 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, I'm looking for the distance from A to B. What is this length? Okay, now I can't count the units because it's on the diagonal and it's not evenly split on a diagonal either. But what I can do is plug it into the distance formula. Here it is. It's the square root of the difference of your x's squared plus the difference of your y's squared. Remember, all of this is under the square root. Okay, so when I plug in my numbers, right, here's my x1, y1, x2, y2. Remember the little numbers just mean which ordered pair it came from. Okay, little 1, first order pair, little 2, second order pair. All right, so let's plug it in. I know it's all underneath the square root. Boom. x2 is 7 minus x1, which is 1. 7 minus 1, quantity squared, plus y2, which is 9, minus y1, which is 1. All of that squared. All right, I'm going to just keep going down the line here and simplify. 7 minus 1 is 6. 6 squared is 36. 9 minus 1 is 8. 8 squared is 64. When I add those together, I get 100. And you should all know that the square root of 100 is 10. So that's telling me that this is 10 units long. If I will show you something, maybe you will think it's cool, maybe you won't, I don't really know. But if I drew a line here, and I drew a line here, oh my goodness, I drew a line, don't worry. And this is a right angle because those are perpendicular. I can count the units, so that's 1, 2, 3, 4, 5, 6. This is 1, 2, 3, 4, 5, 6, 7, 8. On the side, I can be like 6 squared plus 8 squared equals 10 squared. Well, we should already know that, right? 36 plus 64 equals 100, and that is, in fact, true. Hallelujah! But that's pretty cool. I'm just saying, like, you know, to plug it in that distance formula, that was pretty fun and pretty cool that it worked out. Let's look at some more examples to practice. All right, we're going to use the distance formula to find the distance between the 2 points. Simplify the radical if necessary. Remember, that's with the square root. I do not want decimals. So here's my x1, here's my y1, x2, y2. So the difference of my x's, -3 minus 1, all of that squared, plus my difference of my y's, 0 minus 2, all of that squared. -3 minus 1 is -4. When you square a negative, if you're not putting it in parentheses, you're going to get the wrong answer on your calculator. But -4 times -4 is positive 16 all day long. 0 minus 2 is -2. -2 squared is positive 4, because -2 times -2 is positive 4. This gives us the square root of 20. I need to break this down. I know that this is the square root of 4 times the square root of 5, so this reduces to 2 root 5. Okay? Why don't you pause the video at this time, take a second, see if you can use what I've done in number 1 to apply to number 2 if you know what you're doing. I do have more examples, but this is good practice. All right, so you should have gotten the answer was 5. And don't forget when you're subtracting, so -2 minus -2 becomes addition. Be careful about that. Take your time and work the problem down, okay? And you should get positive 5. Let's look at a couple more examples here. I'll do one, you do the other one. I think this will work out pretty nice. All right, so the difference of my x's, right? Don't forget the radical. 1 plus 3, because that's 1 minus -3, plus 2 minus 3. 1 plus 3 is 4. 4 squared is 16. 2 minus 3 is -1. -1 squared is 1. This becomes the square root of 17. 17 is prime. It does not break down, so you finished right there. So why don't you take a second, pause the video, and see if you get the right answer for number 4. Okay, so in number 4, you should have gotten 2 root 2. Remember, the square root of 8, that breaks down. If you want to do prime factorization, 2 and 4, 2 and 2. I got a pair of 2s, meaning 1 comes out front. I have this spare 2. It stays inside. It has no friends to play with. All right, we got one more example with the distance formula just to answer the question, right? It says use the distance formula to decide whether segment AB is congruent to segment BC. So let's first look at AB. Okay, so I have 3 minus -2 is 3 plus 2 squared, and then I have 1 minus 4, all of that squared. 3 plus 2 is 5, 5 squared is 25. 1 minus 4 is -3. -3 squared is 9. When I add this together, I get the square root of 34. So if you're like, oh, let me try to break that down, you're like 2 and 17. Well, they're both prime, there's no pairs, so it does not break down. It is simply the square root of 34. All right, I am going to see if I take the distance of BC, if I get the same. So let's see, we have 0 minus 3 squared plus -4 minus 1 squared. 0 minus 3 is -3. -3 squared is 9. -4 minus 1 is -5. -5 squared is positive 25. And I see that this is headed in the right direction. And I'm so happy. And I'm like, yes, it's congruent. Yahoo! All right, that's all you got to do, right? Don't forget, so you learned 2 new formulas. The distance formula, and I'm going to write them down again. I know they're on your papers I gave you, but just in case. This is the distance formula, or length. Length, how long something is, a distance formula. Okay, and then another formula was midpoint. That's an ordered pair, hence the word point. Boom. This is the midpoint formula. You will need to know these for at least the test that you have. And I think your test is going to be on the 22nd or the 23rd, whatever your in-person date is, okay? Here's your assignment for this evening, or today, this afternoon, whatever. Get it done as soon as possible. Why not? And again, if you have any questions, please let me know. All right, this looks like a lot, but it really isn't. 3 to 22, 25 to 28, 31 to 33, 43 to 44. And the little dash just means you have to do all the numbers in between. All right, please make sure you write this down and get it completed. You can submit it to the Dropbox, which I prefer because I won't see you tomorrow because tomorrow's Wednesday. I mean, I'll see you online. But yeah, okay. And again, if you have any questions, let me know. I'll be around. Adios.